Here we have a SAT math problem. Okay, let's go to the question. Squares ABCD and DEFG with integer length sides of B and A respectively are shown in the figure above. If the area of the shaded region is 28, what is the area of square ABCD? Okay, we have to find the area of the square ABCD, that is the bigger square over here. Okay, we know that the length of each side of the smaller square DEFG is A. Then the area of this smaller square is A square. That is, we have to multiply the side by side to get the area of a square. Okay, we know that the length of each side of the bigger square ABCD is B, that is given over here. Now to get the area of the bigger square, we have to multiply this B by itself, that is B square is the area of the bigger square. Okay, now to get the area of the shaded region, what I have to do is, I have to subtract the area of the smaller square DEFG from the area of the bigger square ABCD. Let me write the stuff over here. We have the area of the shaded region, let me write it, area of the shaded region equals to 28. Okay, now to get the area of the shaded region, we have to take area of square ABCD first. Okay, from the area of the bigger square ABCD, we have to subtract the area of the smaller square, that is DEFG equals to 28. Okay, what is the area of the bigger square ABCD? That is B square, because the length of each side of the bigger square is B. So then to get the area, we have to multiply the side by itself, that is B has to be multiplied by itself, that is B square. Negative area of the smaller square is A square, that is A times A equals to 28. Okay, now we can consider the algebraic identity to factor this B square negative A square. So that is, let's consider the algebraic identity, that is x square negative y square. Actually, it is called difference of two squares. Whenever we have difference of two squares, it can be written in the factored form, that is x positive y times x negative y. Okay, now let's consider the expression we have over here. It's exactly in this form, x square negative y square. At the place of x we have b, at the place of y we have a. Okay, now to get the factored form of this expression, we have to use this stuff, x positive y, x negative y. At the place of x we have to write b, at the place of y we have to write a. In that case, I am getting b positive a times b negative a equals to 28. That is the product of two binomials b positive a and b negative a equals to 28. Okay, here let's consider the values of b and a. So the question clearly says b and a are integers. And also, since b represents the length of each side of the bigger square ABCD and a represents the length of each side of the smaller square DEFG, both a and b must be positive integers. Okay, here we have addition of two positive integers, here we have the difference of two positive integers. Always the addition of two positive integers will be greater than the difference of two positive integers. Since the product of two quantities over here equals to 28, now we can write all possible pairs of factors of 28. Let me write it. Okay, now if I consider the number 1 over here, it must be 28 over here, so that when I multiply this 1 and 28, that is equal to 28. And now let me take 2, then it must be 14 over here, so that 2 times 14 is 28. And we cannot take 3 over here because 28 is not a multiple of 3. Now we can consider 4. 28 is a multiple of 4. When you take 4 over here, then it must be 7. So that 4 times 7 is 28. And 28 is not a multiple of 5. And also 28 is not a multiple of 6. 28 is a multiple of 7. So we can take 7. Then it will be 4 over here. 7 times 4 is 28. Then we'll have 14. And here we'll have 2. Then we have 28. Then we'll have 1. Okay, now let's consider the values we have over here as b positive a, the values we have over here for b negative a. As I said already, b positive a is the addition of two positive integers. It has to be greater than the difference of two positive integers b negative a. So then we have to reject the pairs where we get the value of b positive a is less than b negative a. We have to reject the first one because 1 is less than 28. We have to reject the second one, the third one for the same reason. We can consider this pair because in this pair the value of b positive a is greater than the value of the b negative a, 4. So now we can write b positive a equals to 7 and b negative a equals to 4. Okay, now let's solve for b and a in these pairs of, in the system of equations we have over here. So positive and negative will cancel out. I am getting b positive b is 2b, and the right side 7 positive 4 is 11. When I divide both sides by 2, this 2 will cancel. I am getting b equals to 11 over 2 is 5.5. I am getting a decimal value for b, but according to the information, so integer length sides of b and a, that is both b and a are integers. So when I take b positive a as 7 and b negative a as 4, I don't get an integer value for b. So we can reject this particular pair as well. Okay, now let me consider the 14 as a value of b positive a and 2 as a value of b negative a. Let me write it. Okay, now let's solve this system. So positive and negative will cancel out. B positive b will be 2b. 14 positive is 16. When I divide both sides of this equation, so this 2 will cancel. I'm getting b equals to 16 divided by 2 is 8. Okay, now I got the value of b as an integer, that is 8. Okay, when I plug in this value 8 for b in one of these two equations, I will be able to get the value of a. Let me take the first equation over here, that is b positive a equals to 14. When I plug in b equals to 8, then we get 8 positive a equals to 14. Now when I subtract 8 from both sides, then positive 8 negative 8 will cancel. I'm getting a equals to 6. When b is equal to 8, I'm getting a equals to 6. So it meets the condition given in the question, that is both b and a are positive integers. Anyways, we can check the last pair, that is 28 and 1. That is, we have to plug in 28 for b positive a and 1 for b negative a. Let me do it. 28 and 1. Let's solve this system. Positive and negative will cancel out. 2b equals to 29. Let's divide both sides by 2. When I do so, this 2 will cancel out, and b equals to, when I divide 29 by 2, I am getting 14.5. I don't get an integer value for b, so I have to reject the last pair of factors as well. Okay, now let's consider the value of b. Already we got it. So that is b is equal to 8. Already we know that the area of the square ABCD, that is a b square. So when b is equal to 8, then b square equals to 8 square. 8 square is 64. Therefore, the area of the square ABCD is 64 square units.